It's an exponential equation because your variable is in the exponent. To solve an exponential equation, step one is to isolate the exponential term, right? And this one's already isolated. Then you can change it to log form. Could everyone write that in log form? Then I'll show you another way to work this one. How would you write that in log form? Because that's just the inverse, right? Do the inverse. In log form, it's exponent, so 7x equals log, what's your base? 3 of 27. Again, that's just that formula from the last test to go from one form to the other. And then can't you evaluate log base 3 of 27 with an E1 calculator? What does that mean? 3 to what power is 27? So this means, you know, when you evaluate a logarithm, you're looking for the exponent, right? It means 3 to what power will give you 27. So what is that? How many times you multiply 3 to get 27?
3.
3. So this is 3. So 7x equals 3. And then it's just a regular algebraic equation now, right? Now how to get x by itself. Come on, this is multiplication. So you divide, right? Divide both sides by 7. So the solution is x equals 7, 23 sevenths. Now, that is the method that always works, right? Using logarithms. But wouldn't this be also one of the types where you could rewrite both sides with the same base and equate the exponents? You know, the other method doesn't always work, but when it works, it's pretty quick. So this is the method of equating exponents. 3 to the 7x equals 27 is 3 cubed, right? If you can write both sides with the same base, then you can just set the exponents equal to each other. And then I can say, well, then 7x would have to equal 3, and then x equals 3 sevenths. You get the same answer either way. So this method always works. This method works when you can write both sides with the same base. You're okay on that one? And the next one, e to the 4x minus 3 equals 9. Now in this one, you can't use this stuff, can you? To try to write that with a base of e would be a lot more trouble than it's worth. I'll just use the method that always works. Step 1, isolate the exponential term. It's already isolated, isn't it? Step 2, change it to log form. If I write that in log form, it's going to be exponent 4x minus 3 equals log, what's your base here? E of 9. Okay? Formula from test 3. Well, log base E is a special log. It's called the what? The natural log. So I'll just write natural log of 9. So ln just means log base E. Now just want to get x by itself. So what do I do to solve for x?
Add 3.
Add 3. So that will leave me with 4x equals natural log of 9 plus 3, or 3 plus natural log of 9. Do not say natural log of 12. These are not like terms. You can't add those, right? As a common mistake students make. And then divide by 4. So the exact answer is 3 plus the natural log of 9 divided by 4. And then if I said round to so many decimals, then you got your calculator, right? So what would that be in decimal form to 2 decimals? So x is approximately, just follow the directions. So we want to do 3 plus natural log 9, close parentheses, equals divided by 4. And then to 2 decimals, I'm getting about 1.30. Anyone agree? So again, to type that in correctly, or a way that would work, 3 plus natural log of 9, close parentheses, right? That's the numerator. So I just went ahead and hit equals. That's your numerator. or put it all in grouping sum. And then divide your result by 4. 1.299, 144. Around to 2 decimals, the 9 goes to a 10, so I have to carry a 1 to the 2. Okay, so practice your calculation, like, screw you how to type these in, right? You gotta tell it to do this, and then divide it by this, right? Everyone's still okay? Okay, then I switched to some log equations. The third one only has one log term, so you don't have to do any condensing, right? It's a single log term. It's already isolated. So all you need to do then is change it to exponential form, do the inverse. In exponential form is what? In exponential form, that's your base, isn't it? That's your exponent, that's what it equals. So in exponential form, its argument, x plus 3, equals the base to the power. It's that same formula but going the other direction, going from log form to exponential form. What is 3 to the 4th power? Yeah, I'm just evaluating this. 3 times 3 times 3 times 3, 81. Excuse me. And then what? Subtract 3 from both sides. So the solution is 78. I want to make sure that that is okay. You have to check log equations. You don't have to check exponential equations because domains are real numbers, but log equations have a restricted domain. Is 78 okay? So it's okay as long as it doesn't make that negative, right? Or 0. So it should be fine. So we're okay with that one. Now, number 4, we have 2 log terms. So that one I need to condense it first, right? If there's more than one log term, use the properties for expanding, condensing. If that is in the expanded form of plus, then when I condense it, it's going to be a what? Product, right? This is the product rule. So I'm going to rewrite that then as log base 4 of x plus 8 times x plus 5. Equals 1. So I used the properties for expanding, condensing from last test to condense it. Now it's just like number 3, isn't it? You have a single log term, it's already isolated, change it to exponential form. So in exponential form, it's what? Argument, this is the argument. So x plus 8 times x plus 5 equals base to the power, right? You know, what a logarithm equals is its exponent, right? So that 1 is the exponent. Well, I can tell by looking that's going to be a quadratic equation. Can't you? Because we multiplied out, we'll have an x squared. So let's go ahead and multiply it out. X times x is x squared. The outer is 5x. The inner is 8x. So that's add up to 13x. And then 8 times 5 is 40. Equals 4 to the first is just 4. So let's get everything on one side and see if it factors. If I subtract 4 from both sides, I'll get x squared plus 13x plus 36 equals 0. Is that factorable? 9 times 4 is 36, 9 plus 4 is 13, right? So x plus 9, x plus 4. If I set each of those factors equals 0, I'll get x equals a negative 9 and x equals a negative 4, right? Now, this is a log equations. I have to check to make sure those numbers are going to be okay. Is negative 9 going to be okay? What is negative 9 plus 8? Is that negative 1? You can't take the log of a negative, can you? You can only take logarithms of positive numbers, so we're not going to use the negative 9. Is the negative 4 going to be okay? It's okay as long as it gives you a positive number and you plug it into the argument. Negative 4 plus 8 is 4, that's fine. Negative 4 plus 5 is 1, that's fine. So your only solution then is the negative 4. So make yourself a note, you have to check the solutions to law of equations. Sometimes you get what's called an extraneous solution. Now, the fifth one, I can kind of work it like I did the last one, but do you remember that method we talked about when you have a single log term on both sides? Log base 3 of x plus 6 equals log base 3 of 2x. When you have a single log term on either side of the equations, then you can also just equate the arguments, can't you? If the log base 3 of this is supposed to equal log base 3 of this, then shouldn't those arguments equal each other? And so this is a technique that doesn't always work, right? But when it works, it's quick. So now I can say, well, x plus 6 would have to equal 2x, wouldn't it? For that to be true. And if I subtract x from both sides, what do I end up with? 6 equals x. Is a 6 going to be fine? Well, 6 plus 6 is 12, that's fine, and 2 times 6 is what? 12, right? So it's okay. It didn't give me a negative number or a 0. So your only solution to that one is 6. That's just a quick sampling of the different methods for solving exponential and log equations, right? So you have a method that always works, then you have a couple methods that work when it is in the right form. And then we did some word problems, right? And really you just had to know where to plug the numbers in the right place. These are definitely calculator problems. The exponential model describes the population A in millions T years after 2005. Well, what would the population be in 2005? Do y'all remember the form? It was like A equals A sub 0 e to the, I think we used a KT. And this was like the ending population after a certain time. This was the what? Starting population, right? And of course, K is your rate, T is your time. So if the question is, what is the population in 2005? Well, isn't that the starting year? Can't you find that just by looking right here? Starting population is 79.5 billion. A sub 0 is what we were asking for. That would just be me seeing if you know how to read the formula, right? The next question says, how many years, so we're looking for time, right? How many years will it take until the population reaches 90 million? So if our starting population is 79.5, when will it get to 90, right? So when will the population end up being 90? So that would be the A, wouldn't it? So I'm gonna put that in the A position. So 90 equals 79.5 e to the 0.023 times t. A sub 0, starting position, uppercase A by itself, ending position, population in this case, not position. Okay, how do you solve that for t? What kind of equation is that? Isn't that an exponential equation? Right? Because why? What makes it an exponential equation? The variable in the exponent, right? There's a t in the exponent. How do you solve exponential equations? We just reviewed the process, right? Get the exponential by itself, change it to log form, and then we're going to use a calculator on these. I need to do something on this one to get the exponential by itself done. I don't want the 79.5. I want it just e to the power. So what are you going to do to isolate the exponential factor? What would isolate e to the 0.023t? Divide by 79.5. So then I'll have 90 over 79.5, and I always just wait till the very last thing to pull out my calculator. Right? That prevents round off error, especially if you're putting your answers in my lab of math. So 90 over 79.5, whatever that is, equals e to the 0.023t. Now it's exactly like the problem we did first, isn't it? It's an exponential equation. The exponential factor is isolated. Now just change it to log form. How do you write this in log form? Let's just do it in the inverse, right? When I write that in log form, it's just exponent, so 0.023t equals log base what? What's getting raised to the power? E. And log base E is just what? The natural log? So it'll be natural log of 90 over 79.5. So again, that's just using the formula from the last test to change it to log form. Everyone okay? And then to get t by itself, don't I just divide by 0.023? So t then equals the natural log of 90 over 79.5 divided by 0.023. And now you got your calculator. Everyone okay so far? Okay, so when I type this in, if you listen up, I'll kind of tell you exactly how to plug this in. So natural log ln, that opens up parentheses. So I'll do 90 divided by 79.5, then I'm gonna close parentheses. That's the end of the log argument, right? The number. Then I need to divide all that by 0.023. And let's just round off to 2 decimals. What are y'all getting? T is about what? About 5.39 years. Now, if the direction said round off to the nearest year, we would say 5 years, wouldn't it? If it said what year is that, what would it be? You know, T is the time after 2005. So 5 years after 2005 would be 2010, if you're asked for the year. So just make sure you answer the question. Everyone still okay? Now notice the next says when, or sorry, what will the population be in 2010? So this time, we're looking for the A, aren't we? You know the starting population. What will the population be in 2010? Well, first, if we know the year, and we know the starting year, can we figure out how many years have gone by? What would T be? From 2005 to 2010 is how many years? 5 years, so T is 5. So that means we're going to go to our equation, our formula, and replace the T with a 5, right? And then that'll give us what the A is, right? So we're looking for the A, right? What is the population going to end up being in 2010? So if I replace the T with a 5, A equals 79.5 E to the 0.023 times T, which we just figured out was 5, right? Now we should have a pretty good idea, right? Should be close to 90 billion, shouldn't it? Because we just figured out that that was about 5 years. This is just a number crunching problem, isn't it? Don't you see all the numbers already on one side? So we don't have to divide by anything or do any of that. You just punch into your calculator. So I can do 79.5 times, I'm going to get my E key, second ln gets my E key, second ln, and then the exponent, I want to do 0.023 times 5. I'm going to close parentheses to end the exponent. What are you getting? to 2 decimals. You're getting 89.19. Doing okay? And when the previous problem said, how long is it gonna take to get to 90 million? We said a little over 5 years, right? So when will the population, what would the population be in 5 years? It should be close to 90 million, shouldn't it? Everyone okay with those? Practice enough of those until you're comfortable with calculator, right? Those are really just calculator problems. The algebra part is pretty easy. You'll get it set up, then grab your calculator and evaluate. Okay. Then we went first 2 equations. You know, step 1 was reduce the system to 2 equations, 2 unknowns, right? And then it had a bunch of bullet points. The first bullet point said pick 2 equations and eliminate a variable. So if we pick the first 2, x plus y plus 3z equals negative 13, and then x plus y plus 6z equals negative 28. And which variable do you want to get rid of? So we picked 2 equations. Now pick a variable to get rid of. You get rid of x's, y's, or z's. It's kind of up to you. What do you think?
X.
X's? Okay, so if we're gonna get rid of x's, we need then the x's to be one a positive x, one a negative x, right? Which one you wanna make the positive x, or which one you wanna leave positive, which one you wanna make negative? So we'll take this one and multiply it through by -1, which is just gonna change the signs, right? Now this one we're just gonna bring across as it is. So I'm just gonna bring that over, x plus y plus 3z equals negative 13. If I multiply this one through by -1, it's gonna be what? Negative x minus y minus 6z equals positive 28. Is everyone okay so far? Well, what happens? Both the x's and the y's go out. That's okay. Don't let it confuse you. Just go with what you have. X's go out, y's go out. That's what I have. What's 3z minus 6z? So negative 3z equals what? 15? Divided by negative 3z is what? Negative 5. Now we said we were going to get rid of the x's. It just happened that we also get rid of the y's. Don't let that confuse you, right? That's the first bullet. The next bullet says pick 2 different equations but get rid of the same variable. So we did 1 and 2 that time. You want to do 1 and 3 or 2 and 3? What are y'all thinking? 1 and 3. Okay, so if I use 1 and 3, so 1 was x plus y plus 3z equals negative 13, and 3 is x plus 7y minus 5z equals 45. And we want to try to get rid of x's, right? Do the same thing you did for step 1. Do you want to multiply the first one through by -1 or the second one? Because it doesn't matter. What do you think? Someone say first one? Okay, so if I take the first equation and multiply through by -1, the effect is it's just going to change the signs, right? So that's going to become what? Negative x minus y minus 3z equals 13. And then this one we're just going to bring across as it is, right? X plus 7y minus 5z equals 45. Is everyone Doing okay so far? X's go out, which is what we were trying to do, same thing with step for step one. What's negative y plus 7y? Isn't that 6y? And negative 3z minus 5z is minus 8z. And then 13 plus 45 is what, 58? Doing okay? Now in your notes, I said call this A, call this B, right? Because that is your new system of two equations, two unknowns. So now we have it reduced to a system of two equations, z equals negative 5, and then 6y minus 8z equals 58. Well, we already know what z is, right? Couldn't we just substitute and find y? So could we use substitution to finish this one out? So since z is negative 5, I'm going to replace z in the second equation. So using substitution, 6y minus 8 times z, which is negative 5, equals 58. And they don't always end up this easy, right? But this one did. That would be 6y plus 40 equals 58. I'm trying to find y. So I'll subtract 40, so I get 6y equals what? 58 minus 40 is 18. And then divide by 6, y is what? 3. So we know z, we know y, now I just need the x. Where do you find x? Or how do you find x? You can go back into any one of the original three, right? So someone said the first one. So we're gonna find x by using the first one. X plus y plus 3z equals negative 13. X plus, what was y? 3. What was z? Negative 5. So it was 3 times negative 5 equals negative 13. 3 times negative 5 is negative 15, right? What is 3 minus 15? So x minus 12 equals negative 13. Got 12 both sides. What is x going to be? Negative 13 plus 12, negative 1. So what is your answer then? What is the ordered triple? Put your x first, negative 1, right? Put your y next, 3, and your z last. And if you want to make sure you didn't make a careless error, what should you do with that solution? Plug it into all three to make sure it works, right? And that's pretty much it for section 8-2, right? How to solve a system with 3 variables. Any questions on that one?
So on the test, well, you'll already give us the x, y, and z, and then we'll just have to plug it in.
On one I will.
Oh, just one?
Yeah, and that would be called checking your solution, right? So it would be what I would do when I finish solving anyway, right? If you plug that into all three, it should work. So if I give you one and say, is this a solution to the equation, then all you have to do is plug it in. But if I give you one like this and say solve it, you gotta go through the algebra part. So I won't give you that solution, right? Any other questions on that one? I gave you a handout with step, right? We've done a couple in class. So make sure you practice a couple of those. They're not hard, but they are long problems. A lot of steps involved. Okay, so then we went to section 8.4. In section 8.4, these were 2 equations, 2 unknowns, which was like the middle part of section 8.2, right? That's why I did this section first. When you're given a system of 2 equations, 2 unknowns, there are 2 methods, the addition method or elimination method, and there's a substitution method. You know, sometimes one method's better, sometimes another method's better, sometimes one's not as easy as the other. Usually you can look at the system and figure it out, can't you? If I gave you that system, and I just said solve it, I didn't tell you to use a particular method, I'm gonna use elimination, aren't you? Cause if you add these two up, aren't the y squares gonna get eliminated? And so that to me would be the obvious method, it's already in the right form, I don't have to multiply by anything. So if I use the elimination method, I'm just gonna add these up. X squared plus x squared is what? 2x squared. Y squares get eliminated. 40 plus 32 is 72. Then I'll divide both sides by 2. And I end up with x squared equals what? 36. Do the square root of both sides. What's x? Positive and negative 6, right? Then I need to find the y's for both of those x's, don't I? When x is positive 6, which one do you want to plug into? Top one? So if I plug a positive 6 in the top equation, I have what? 6 squared plus y squared equals 40, right? 6 squared is 36. Subtract 36 from both sides. Y squared is 4. So what's y? Plus or minus 2. Don't forget to put the plus or minus. So when x is 6, we're getting a positive 2 and a negative 2, aren't we, for the y? So this would be those ordered pairs. When x is 6, we get a positive 2. When x is 6, we get a negative 2. What was the other x?
Negative 6.
So now let's do the same thing for when x is negative 6. If I plug into the first equation again, that'll be negative 6 squared plus y squared equals 40. You're going to get exactly the same two solutions, aren't you? Because the negative 6 squared is still 36. If I subtract 36 from both sides, you get y squared is 4. So again, y is plus or minus 2. So when x is negative 6, y can be positive 2 or negative 2, right? So how many points of intersection are we finding then? 4 solutions. So that must mean these two graphs intersect 4 times, right? Which is what you're finding graphically when you're solving a system. The first equation is a circle, the second equation is what's called a hyperbola. You don't have to graph these to solve. You have a circle, you have a hyperbola coming in like this, so it intersects 1, 2, 3, 4 times. You're okay with that? Okay, I'm gonna leave the substitution method for you, and not do both, because that was the obvious method on that one. But if you use substitution, you get the same 4 solutions. Just keep that in mind if you're gonna practice that. And then the last section was section 8.5. This was graphing inequalities and then solving a system of inequalities by graphing, finding where the two shadings overlap. So if you're graphing an inequality, you just graph like you normally would and shade the appropriate side, right? So y is greater than or equal to x squared minus 9. I'm going to graph the equation first. So first I'm going to graph y equals x squared minus 9. Then I'll take care of the shading, the greater than part, okay? So if you're going to graph y equals x squared minus 9, I hope you all recognize what kind of graph it is. What is it?
Vertex.
It's what?
Vertex.
Yeah, it's a parabola, right? It's a parabola. Good. It's a quadratic function whose graph is a parabola. I'm just putting in my x-y axis here. If I were going to graph that parabola, I'd probably want to find the x-intercepts. Do you agree? So all this is going back to previous tests, right? How do you find x-intercepts? You let y be 0, right? I put a 0 in for the y, so So 0 equals x squared minus 9. Add 9 to both sides. Take square root of both sides, don't forget the plus or minus. So we have two x-intercepts, don't we? Positive and negative 3. Doesn't this quadratic function open upward? Because the coefficient of x squared is 1, positive, right? So it opens upward. Let's get the y-intercept. How do you find the y-intercept? Let's put a 0 in for the x, right? So if I put a 0 for the x, have y equals 0 squared minus 9. So where's the y-intercept? Negative 9? I'm going to count by 2s because I don't have enough for x. Negative 2, negative 4, negative 6, negative 8, negative 10. Now these I count by 1s. So the y-intercept's at negative 9. So maybe about right here. We mentioned this when we were graphing parabolas. The vertex is always halfway between the x-intercepts. So wouldn't that be your vertex? And that halfway between the x-intercepts. Now I'm going to start my graphing part. This was greater than or equal to. So I draw the parabola solid, right? I draw it solid because of the equal to part. So that's the equal to part. Now I just got to figure out where to shade for the greater than. You think we go inside the U or outside the U? We have just graphed y equals x squared minus 9, right? Now we got to do the greater than part. Well, if you're not sure, test a point. So do you think we shade inside the U or outside? Because that's what it is. The parabola divides it into two areas, right? Inside or outside the U. This does not go through the origin, so let's test using 0, 0. If 0, 0 works, that was inside the U, I'll shade inside the U. If 0, 0 doesn't work, then I'll shade outside the U. So I'm testing by putting a 0 for the x and a 0 for the y. So the inequality, I'm going to replace y with 0, greater than or equal to 0 squared minus 9. Is that a true statement? Is 0 greater than or equal to negative 9? Yes, that's true, right? So I shade inside. What graph is the next one? 2x plus y equals 3. Now graph it like it's an equation and take care of the inequality part. What kind of graph is that? You should start to be able to recognize certain graphs, right? What is that? It's a line, right? ax plus by equals c, or in slope-intercept form, y equals mx plus b. And to graph that, you can do the intercept method. You can put it in y equals mx plus b form. You can do table values. Just how do you want to come up with 2 points? There's only be 2 points to draw on.
Intercept.
So just move the 2x over, or do the intercept method. Sorry.
Intercept.
X and y intercept.
Yeah.
Okay. Yeah, the intercept method is easy on this one, isn't it? So in the intercept method, you're saying when you get the x-intercept, what do? Let y be 0. And if y is 0, what happens? It's gone, right? So 2x is 3, so what's x? 3 halves. And then to get the y-intercept, you're going to let x be 0, right? And if x is 0, cover up the x term, what do you got? Y equals 3. Quick way to get 2 points. So what do we have? X is 3 halves. I'm going to count my ones on both of these. So 3 halves is 1 1/2. So maybe about here. And 3 here. Now, if you wanted to do slope-intercept form, you would have y equals what? Negative 2x plus 3. Right? So where's your y-intercept? 3. What's your slope? Negative 2 over 1. So I could have done what? Down 2 over 1. You can see that those wanna get 2 points, that doesn't matter. So I'm gonna draw the line, but I'm gonna check my inequality first. Do I make the line solid or dotted? Or dashed? Dotted, right? Cause it's not greater than, equal to, less than, equal, so I'll make it dashed. Okay. So here's the line dashed in. And now I just have to take care of the less than part. Do you think we shade the upper right or lower left? How do you decide how to shade if you're not sure? Just test a point, right? You can't test a point on the line, but any other point you can use for testing. And I just suggested the origin because it's easy, right? So if I'm testing, and you can probably do this in your head. I might test using 0, 0 because I can, right? Does 0, 0 make a true statement in that inequality? Is 2 times 0 plus 0 less than 3? I'm just asking that question. It is, right? 0 is definitely less than 3, so that's a yes. So 0, 0 works, it's on this half, so that's half you shade. Okay? So graph as you normally do, and then pick whether it's dotted or solid, right? Then decide which part to shade. And if you can do those, the other part of this section was kind of putting it together in the system, right? So you do the same thing. You graph, you shade, you graph, you shade. The solution to the system is where the shadings overlap each other. And if you've done that in my lab, remember I told you last time, in my lab, you have to kind of figure out the correct area to shade off paper, on your paper, and then just shade the answer. Because the answer is the overlapping part. Did we just graph this one? Wasn't that parabola opening upward, x-intercept quadrant 3, -3, y-intercept -9? 0 degree? Okay. So let me put in my x-y axis. I won't go through that all again. I did that just to save time. See how we're doing on time. I think we're okay now. Alright, straight. So graphing the first one, that was the parabola opening upward. The x-intercepts were +3, -3. Remember, I counted by 2's on the y-axis, right? So I'm gonna go down to -9. So -2, -4, -6, -8. So this is -10. -9 would be about here. So I counted by 1's on the x, and I counted by 2's on the y. Now, the inequality was greater than or equal to, so I'm gonna make that parabola solid. And didn't we figure out that we shade inside? So I'm gonna try to not be so messy, so we can figure out what our answer is. So the only thing different about these, you're just putting 2 graphs together, right? And seeing where they overlap. What about x squared plus y squared equals, is greater than or equal to 9? I told you, we hadn't done circles before. I want you to know how to graph a circle now. Remember that x squared plus y squared equals r squared? It's a circle with a center at 0, 0, and the radius is whatever the r value is, right? So if it's x squared plus y squared equals 9, that's going to be a circle whose center is at the origin with a radius of what? 9 is the same as what, 3 squared? So the radius would be 3. So I'm just going to go from the origin. I'm go out from the origin. Everyone knows where the origin is, right? The center where the x and y intersect each other. So I'm going to go out 3. I'm going to go up 3. And my scale's going to be bad because of the 2's. Let me do this over. Oh, I think about the circle. The scale making it look like an ellipse. You don't have to race. You don't have to be perfect, but I hate to leave you with such an imperfect answer. So here's my y-axis. Draw it in straight like that. multiply by 2 on both, okay, just so it's proportional. So then the parabolas, x-intercepts were 3 and, what is it, 3 and -3, right? I'm just counting by 2's now on both. And the y-intercept was -9, 2, 4, 6, 8, -9. It was greater than or equal to, so opening upward and solid. And then we said we shaded inside, right? Now I'm going to go back and put the circle with radius of 3. So from the origin, from the middle, I'm gonna go over 3 this way, up 3 this way, left 3 this way, and down 3 this way. As you can see, if I counted by 2's, it would have been an ellipse instead of a circle. And the circle is greater than or equal to, so I'm gonna draw it solid. Now do I shade inside the circle or outside the circle? What do you think? If I shade inside, 0, 0 would have to work, right? If it doesn't work, I have to shade outside. So if I put a 0 in for testing, is 0 squared plus 0 squared greater than or equal to 9? No, that's not true, is it? 0, 0 is inside, didn't work, so I shade outside. So now I'm trying to go outside and shade this. Do you see where the 2 overlap? Where do you see red and blue? Definitely in here, you agree? I'm just gonna try to darken the edge. That's what you would do in my life. You click in this little area, it'll automatically shade it for you. And then I see red and blue again down here. You agree? Okay, so that's the solution to the system. Let me give you a second to try the last one, right? So we're gonna graph the first one like it's a line and we'll shade the appropriate sides. If I'm graphing x plus 2y equals 4, wouldn't that intercept method work well there? What's the x-intercept?
4.
Square root of the y, right? Because you put 0 for the y, so x is 4. 1, 2, 3, 4. What's the y-intercept? If you put a 0 for the x is gone. So 2y equals 4, so what's y? 2. I'm gonna look at my inequality, so less than or equal, so I'm gonna draw my line solid, not dashed. And then I need to decide where to shade. Do I shade above or below? So there's the equal to part, right? Now where's the less than part? Am I above or below? Do I shade here or do I shade here? Do you know how to figure out which part to shade? You test a point, right? It doesn't go through the origin, so I test using 0, 0, right? If 0, 0 works, I shade this half, right? If 0, 0 doesn't work, I shade the other half. I'm testing it in my inequality. So is 0 plus 2 times 0 less than or equal to 4? Either that's yes or no. Is that a true statement? Is 0 less than or equal to 4? Yes. And 0, 0 was on this half, so I shade that half of the line. Okay? Any questions on that? Now what about the other one? X is greater than 2. I'm gonna graph x equals 2, right? I'm gonna graph it like it's an equation. What kind of graph is x equals 2?
Vertical.
Vertical line through 2. So I'm going to go to x equals 2, and I'm going to draw a vertical line. Is it dashed or solid? Dashed. So x equals 2 dashed because of inequality. Now I just need to shade the greater than part. This one should be obvious, right? right? Where are x's greater than two? To the right or to the left? Has to be to the right, doesn't it? So that one's, then we'd have to test anything, so that goes this way. Where are you seeing red and black? That's the solution to the system. Everyone see their area? It's in here, isn't it? So my lab only wants that answer, right? They don't want you, they won't do the overlapping for you. You have to figure that on paper, then go back and shade those areas. Here's your answer.